This is Spacetime, Series 26, Episode 143, for broadcast on the 29th of November 2023. Coming up on Spacetime, the discovery of a triple star system that will mean changing the astronomy textbooks. NASA tests its new deep space laser communication system, and a Dragon arrives at the International Space Station. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers have discovered some of the biggest stars in the universe orbiting each other in a triple star system. The remarkable new observations involve a subset of massive spectral type B blue-white stars known as BE stars, which until now were thought to only exist in binary star systems, not as triple stars. This groundbreaking new discovery will revolutionize science's understanding of stellar evolution. See, spectral type B blue-white stars are considered an important testbed for developing theories on how stars evolve. BE stars are a non-supergiant B star whose spectrum has, or had at some time, one or more Balmer emission lines, which are a very specific set of spectral lines for hydrogen. Although the BE-type spectrum is most strongly produced in type B stars, it's also been detected in hotter spectral type O blue stars and in cooler spectral type A white stars. BE stars are primarily considered to be main sequence stars, but a number of subgiants and giant stars have also been included. What makes them BE stars is the fact they're surrounded by a characteristic plasma disk very similar in appearance to the rings around Jupiter. And although BE stars have been known about for 150 years, having first been identified back in 1866, until now no one's been exactly sure how they're formed. Consensus among astronomers suggests that the disks are formed by the rapid rotation of the star, which is caused through a gravitational interaction with a companion star in a binary system. However, by analysing data from the European Space Agency's Gaia spacecraft, astronomers have found evidence that these stars actually exist in triple systems, with three bodies interacting with each other instead of just two. One of the study's authors, Jonathan Dodd from Leeds University, says the clue was observing how the stars moved across the night sky over long periods of time, ranging from 6 months to 10 years. Now, if a star moves in a straight line, we know there's just the one star there. But if there's more than one star in the system, generally there'll be a slight wobble, or in the best case, a spiral, due to the gravitational interaction between the two stars orbiting around each other. Dodd and colleagues were applying this across two groups of stars they were observing, one group containing B stars and the other BE stars. But what they found was confusing, because at first it looked like the BE stars had a lower rate of companions than the B stars. And that was interesting because they expected them to be binary systems. However, after looking at additional data over a wider area around the BE stars, they eventually found faint companion stars further away from the primary. So, by looking for wider stellar separations, they discovered the rate of multi-star systems was similar in both B and BE stars. And by further observations, they were able to infer that in many cases a third star was also coming into play, forcing the companion closer to the BE star, close enough that the mass could be transferred from one star to the other, forming this characteristic BE stellar disk. The findings, reported in the Journal of the Monthly Notices of the Royal Astronomical Society, could also explain why astronomers don't usually see these companion stars. They're simply too small and faint to be detected after the primary star usurps much of their mass. The discovery could have a huge impact on other areas of astronomy, including science's understanding of black holes, neutron stars, and gravitational wave sources, such as merging neutron stars and black holes. Dodd says we know these enigmatic objects exist, but we don't know much about the very high-mass spectral type O and B stars that may eventually become BE stars. The new findings will provide a clue to understanding these gravitational wave sources. This is Spacetime. Still to come, NASA tests a new deep space laser communication system, and Dragon arrives at the International Space Station. All that and more still to come on Spacetime.
This episode is brought to you by Dragon Ball Legends, the ultimate Dragon Ball experience on your mobile device. Dragon Ball Legends features action-packed anime action RPG gameplay with Goku, Vegeta, Trunks, and all your favorite Dragon Ball characters. Summon your favorite characters from popular Dragon Ball anime series, such as Dragon Ball Z and Dragon Ball GT to Dragon Ball Super. Fight in real time against friendly or rival Dragon Ball players from across the globe in live PvP battles. Enter ratings matches with your favorite Dragon Ball characters and earn rating points and rewards. Unite with friends to defeat powerful foes in co-op. Dragon Ball Legends features the best anime fighting scenes on your mobile device. And now, Legends Festival is on, so you can get up to 300 free summon tickets. Are you ready? Download Dragon Ball Legends today. Available for free on both iOS and Android devices.
This is Space Time with Stuart Gary.
NASA's just completed an experiment that will literally transform the way spacecraft communicate in deep space. The Deep Space Optical Comms demo, which is mounted aboard the Psyche spacecraft, has just achieved first light, sending data by laser to Earth from beyond the Moon for the first time. The near-infrared laser beamed an encoded signal with test data from nearly 16 million kilometres away, about 40 times further than the Moon is from Earth. The signal was sent to the Hale Telescope at Caltech's Palomar Observatory near San Diego in California. It's the most distant demonstration of optical communications ever undertaken. The technology was configured to send high-bandwidth test data to Earth during a 2-year technology demonstration as Psyche travels to the main asteroid belt between Mars and Jupiter. NASA's Jet Propulsion Laboratory in Pasadena, California, manages both the Laser Communications Experiment and the Psyche mission. The demo achieved first light after its Flight Laser Transceiver, a cutting-edge instrument aboard Psyche capable of sending and receiving near-infrared signals, locked on to a powerful uplink laser beacon, which is being transmitted by the Optical Communications Telescope Laboratory at JPL's Table Mountain facility near Wrightwood, California. The uplink beacon helped the transceiver aim its downlink laser back to the Palomar Observatory 130 kilometres south of Table Mountain, while the transceiver and ground stations fine-tuned its targeting systems. NASA's Director of Technology Demonstrations, Trudy Cortez, says achieving first light was one of many crucial milestones in the coming months. These are all paving the way towards higher data rate communications capable of sending scientific information, high-definition imagery, and streaming video in support of sending humans to Mars. The primary objective of the experiment was known as closing the link, which involves sending test data simultaneously along both the uplink and downlink lasers. With successful first light, the team are now working on refining the systems that control the pointing of the downlink laser aboard the transceiver. Once that's achieved, the project can then begin its demonstration of maintaining high bandwidth data transmission from the transceiver to Palomar at various distances from Earth. The data takes the form of bits encoded in laser photons. After a special superconducting high-efficiency detector array picks up the photons, new signal processing techniques are used to extract the data from the single photons that arrive at the Hale Telescope. The experiment aims to demonstrate data transmission rates up to 100 times greater than the current state-of-the-art radio frequency systems used by spacecraft. Now, whether it's laser or radio, the signal won't get there any faster, as both are travelling at the speed of light. Both radio and near-infrared laser communications utilize electromagnetic waves to transmit data. But the near-infrared laser can transmit a far greater amount of data at a time. While optical communications has been demonstrated in low Earth orbit and out to the Moon, the new system called Deep Space Optical Comms, or DSOC, is the first test conducted in deep space. The demonstration also needs to compensate for the time it takes for light to travel from the spacecraft to the Earth over vast distances. At Psyche's furthest distance from Earth, DSOC's near-infrared photons will take about 20 minutes to travel back. They took about 50 seconds to travel from Psyche to the Earth during the first test run. In that time, both the spacecraft and the planet have moved relative to each other, so the uplink and downlink lasers need to be constantly adjusted for the change in location. Meanwhile, the Psyche spacecraft is continuing on its mission to the metallic asteroid Psyche. It's carrying out its own checkouts, including powering up its propulsion systems and testing instruments that will be used to study the asteroid when it arrives there in 2028. This report from NASA TV.
In our everyday lives on the ground, we use optical fibers for really high-speed communication, and that capability has been adapted for use in space near Earth. DSOC stands for Deep Space Optical Communications, which is using lasers to communicate at high rate, and the application of that to deep space beyond the moon is what the DSOC project is about.
Primary objective is to give future NASA missions the tools for returning data at much higher rates.
The signals travel at the speed of light, so they come just as fast as they do for the microwaves, but you could send more data in the same time of a pass for the same spacecraft resources. The notion of being able to communicate, have video to astronauts on Mars is actually part of the vision that NASA has for optical communications. DSOC consists of a flight terminal that flies on the Psyche spacecraft, and then a ground network that has a station for transmitting up to the spacecraft and then receiving the laser signal down from the spacecraft.
Here we have to send a laser beam from Earth that the spacecraft has to receive, use as a pointing reference, and then initiate the communication link. So it's a very flight and ground joined at the hip kind of telecommunication system.
DSOC is being implemented as a technology demonstration to show that we know how to build terminals that can do this, with the idea that in the future they can be flown as part of the operational communication system on future missions. And we designed the terminal to operate out to about Mars' farthest distance, and Psyche on its cruise actually does a Mars flyby, so it's an excellent vehicle for the demonstration of deep space optical communication. DSOC is the first time that there'll be optical communication demonstrated beyond the moon.
The leap that DSOC is taking is huge. I can't express in words, what this will mean to actually see bits that were transmitted from deep space spacecraft received on the ground, and we can verify that, hey, we got the bits that you sent, here they are. Before that moment of elation and joy, there's a lot of work that we still need to do and think through.
And so this is a stepping stone for a future operational capability that NASA's committed to. There's a lot of activity in space and a lot of collaborative work that goes on, and it's very exciting to be part of.
And in that report from NASA TV, we heard from DSOC Program Manager Bill Kelpstein from NASA's Jet Propulsion Laboratory and DSOC Project Technologist Abby Biswas, also from JPL. This is Space Time. Still to come, a SpaceX Dragon cargo ship carrying 2,950 kilograms of supplies has successfully docked to the International Space Station. And later in the science report, critically endangered dolphins off the Melbourne coast have been found to contain high concentrations of dangerous chemicals. All that and more still to come on Space Time. A SpaceX Dragon cargo ship carrying some 2,950 kilograms of supplies has successfully docked to the International Space Station's Harmony module. The Commercial Resupply Service's CRS-29 mission had launched earlier the previous day aboard a Falcon 9 rocket from Pad 39A at the Kennedy Space Center at the Cape Canaveral Space Force Station in Florida.
And we are at T-minus 1 minute, 5 seconds and counting. Soon the Falcon 9 computers will enter startup mode.
Falcon 9 is in startup.
And there we have the call from the launch director. Falcon 9 computers have entered startup mode, and the Dragon spacecraft is on internal power. Both stages are now pressurizing for launch.
LD, go for launch.
And there we have the on-time call of the SpaceX launch director verifying we are go for launch this evening. Liftoff scheduled for 8:28 p.m. Eastern Time and 14 seconds. At launch, the International Space Station will be flying 459 miles over the Arabian Sea near the coast of Oman.
T-minus 5, 4, 3, 2, 1. Ignition. Liftoff.
And liftoff of CRS-29 carrying cargo, research, and
laser downrange,
and a laser communication.
Engine pressure is nominal.
A laser communications demonstrator to the International Space Station, now in its 25th year of orbital operations.
Nominal power and telemetry.
At T plus 40 seconds, Falcon 9 has successfully lifted off from historic Launch Complex 39A in Florida. We are now coming up on max Q in just about 15 seconds or so. That is
Falcon 9 and supersonic.
That's the point of maximum aerodynamic pressure that the vehicle will go through during its flight.
Max Q.
Great call out there. We have passed through Max Q. Now with that, we have 5 events coming up that will be back to back. First will be main engine cutoff. Those 9 Merlin engines are lit up right now, but we will have MECO, which is main engine cutoff, and that's where we'll shut down all of those engines. That'll slow the vehicle down in preparation for the next event called stage separation, which is where the first and second stages will separate from each other. Then the first stage will perform a flip to head back to our launch site for landing, while the second stage continues to light its Merlin vacuum engine to boost Dragon to low Earth orbit during SES-1 or second stage start 1. And the last event will be the first stage starting up its 1 minute long boost back burn.
MECO.
Stage separation confirmed.
Stage 1,
ignition.
boost back startup.
The first stage heading back to land and the MVAC engine lit up. The first stage in its boost back burn. Again, this is just about a minute burn for this boost back burn on the first stage. It is the first of 3 burns required to bring the first stage back to landing zone 1.
Stage 1, boost back shutdown.
That concludes the boost back burn for the first stage vehicle. This is SpaceX's 81st mission for 2023 and the 6th and final Dragon flight to the International Space Station this year. Today's mission marks the 2nd flight for this Falcon 9 booster, which previously supported the Crew 7 launch earlier this year in August. This is also the first return to launch site for a cargo mission, which helps improve refurbishment and relight times for Falcon 9. For the first stage, in order to make its way back to landing zone 1, it does have a couple more burns to execute. The next burn is the entry burn, and that's where we will relight
Vehicles
3
are
of
on
the
a
9
nominal trajectory.
Merlin brake callouts there. Nominal trajectories for both vehicles. The entry burn is where we will relight 3 of the 9 Merlin 1D engines. This will help to slow the stage down as it re-enters back into the upper parts of the Earth's atmosphere. Then the third and final burn will be the landing burn. That is a single engine burn. The center E9 engine helps bring the vehicle's speed down rapidly just before touching down on the landing zone. And again, the M1D engines have about 190,000 pounds of thrust, which is just enough lighting 1 engine to touch down for landing today. We are just about 15 seconds or so away from that entry burn beginning on the first stage vehicle. We do use 4 grid fins on the first stage to help guide the vehicle back to its landing zone. They are 4 hypersonic grid fins comprised of titanium that are positioned near the top of the first stage.
Stage 1, entry burn startup.
There's that call out. The entry burn has begun. This burn will last just about 15 seconds.
Stage 1, entry burn shutdown.
And very quick burn. That concludes the entry burn for the first stage vehicle. And
Stage 1, FTS is safe.
The vehicles continue to follow a nominal trajectory.
the first stage vehicle also has 4 landing legs near the base of the vehicle, and that they
Stage 1,
are
transonic.
they're deployed just a few seconds before touchdown of the vehicle. And if successful, this will mark the 243rd time that we've recovered a first stage booster, and that includes Falcon 9 and Falcon Heavy missions.
Stage 1, landing burn.
There's that call out. The landing burn has begun.
Stage 1, landing leg deploy. Stage 1, landing confirmed.
And an awesome sight to see. The Falcon 9 first stage that supported today's mission landed for its 2nd time and has previously supported the Crew 7 mission in August earlier this year. This marks the 238th successful landing for an orbital class rocket. Now, next up in a few seconds, just about 20 seconds or so, will be the shutdown of the MVAC engine. That event is called SECO, or second engine cutoff, and that'll be the first shutdown of this MVAC engine.
SECO, nominal orbit insertion.
Great news. We have just had SECO and heard a confirmation of good nominal insertion.
The flight was the 29th Dragon cargo mission to the orbiting outpost. Included in the manifest were 2,381 kilograms of pressurized cargo and 569 kilograms of unpressurized equipment and supplies. The goods included 1,012 kilograms of new scientific equipment, 491 kilograms of general equipment for the space station, 681 kilograms of crew supplies, 48 kilograms of spacewalk equipment, and 46 kilograms of computer resources. The new scientific experiments include research equipment to test enhanced optical laser communication systems, just like the ones we were speaking about in a previous story. The experiment's designed to relay high-resolution data to NASA's Laser Communications Relay Demonstration System, which is in geostationary orbit. As mentioned earlier, the system uses infrared lasers to send and receive information at higher data rates than traditional radio frequency systems, making it possible to send more images and videos to and from the space station in a single transmission. This is all part of long-term designs for future laser communication systems on orbiting spacecraft both at the Moon and further afield at Mars. Another experiment brought to the orbiting outpost uses infrared imaging to measure the characteristics, distribution and movement of atmospheric gravity waves generated by air being disturbed, much like waves created by dropping a stone into a pond. Gravity waves, not to be confused with gravitational waves, play a role in transporting energy and momentum within the climate system and help define climate and its evolution. Scientists also want to know how atmospheric gravity waves are impacted by the solar wind and other space weather events generated by the sun. Other research is looking at ovarian and estrogen signaling dysfunction, adaptation and recovery in microgravity. This could help identify and treat the effects of stress on ovulation and improve bone health on Earth. Then there's the Aquamembrane 3 experiment. It'll evaluate replacing multi-filtration beds now used for water recovery on the space station with a new type of filter known as an aquaporin inside membrane. These are membranes that incorporate proteins found in biological cells known as aquaporins to help filter water faster using less energy. Another experiment will study how mucus lining the respiratory system affects the delivery of drugs carried in a small amount of injected liquid known as a liquid plug. By conducting the research in microgravity, it makes it possible to isolate the factors involved and help develop targeted respiratory treatments. The Dragon cargo ship will remain docked to the space station for 11 days before returning to Earth with completed experiments and equipment. This is Space Time.
This episode is brought to you by Shopify. That's the sound of switching your business to Shopify, the global commerce platform that supercharges your selling. Harness the best converting checkout and same intuitive features, trusted apps, and powerful analytics used by the world's leading brands. Stop leaving sales on the table. Discover why millions trust Shopify to build, grow, and run their business. Sign up today for your $1 per month trial period at shopify.com/tech23.
First, the bad news. SAP Business AI won't help you generate cubist versions of your family's holiday photos. But it will help you understand which supplier is best to help you roll out your plant-based packaging in Southeast Asia, or identify the training your junior project manager needs to rise up the ranks, and automate repetitive tasks while you focus on big innovations, so you can be ready for the next opportunity. Revolutionary technology, real-world results. That's SAP Business AI.
And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Critically endangered dolphins found in the waters off Melbourne and Gippsland have been found with the highest concentrations of chemicals known as perfluoroalkali and polyfluoroalkali substances of any dolphins anywhere in the world. The chemicals are widely used in everything from food packaging and firefighting foam to non-stick cookware, and they're notoriously known as forever chemicals because they never break down. The joint study by scientists from the Marine Mammal Foundation, RMIT and Melbourne University found alarmingly high concentrations of the chemicals in Victoria's critically endangered Brunan dolphins. Samples were taken from 38 dolphins of various species found stranded along the Victorian coastline, but especially high perfluoroalkali and polyfluoroalkali substance liver concentrations were found among dolphin populations in Port Phillip Bay and the Gippsland Lakes. A report in the journal Science for the Total Environment found average concentrations of some of these chemicals in these populations were more than 10 times higher than what scientists believe is necessary to cause liver toxicity and a range of health issues. In fact, one juvenile dolphin in Port Phillip Bay had a liver concentration of 19,500 nanograms per gram, the highest level ever recorded in any individual dolphin globally. The study's authors say the results are both highly concerning and globally significant. A new study has found that people with a higher body mass index are at least 10% more likely to develop obesity-related cancers such as colorectal, kidney, pancreatic, and ovarian. And that's likely to be the case even if they don't have a cardiometabolic condition such as heart disease or type 2 diabetes. The findings, reported in the journal BMC Medicine, are based on data from nearly 600,000 British people as part of investigations into how cardiometabolic conditions interact with higher body mass indexes, a metric used as an approximate measure for overweight or obesity and cancer risk. The authors say for those without a cardiometabolic disorder, a 5-point increase in body mass index score was associated with an 11% increase in obesity-related cancers. They say the risk's especially high for those who are obese and have heart disease, so weight loss could be especially important for this group in order to reduce their cancer risk. Well, it seems the days of weather forecasts often being wrong could soon be over, thanks to Google's DeepMind artificial intelligence proving to be better and faster at making 10-day weather predictions than existing costly and complex numerical weather prediction methods, beating them 90% of the time. The findings, reported in the journal Science, showed that the DeepMind AI was also better at predicting extreme weather events, such as heat waves, extreme cold, floods, and even tropical cyclones. The authors say DeepMind shouldn't be thought of as a replacement for current weather prediction methods, but it can complement and improve them. Well, the big story of the past few weeks in the technology world has been the ructions surrounding OpenAI CEO Sam Altman. He was fired as ChatGPT boss, then hired by Microsoft, but may now be set to be rehired by OpenAI. With the details of this ever-changing soap opera, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yes, well, he's gone from his own company to Microsoft, and now he's come back to OpenAI. I mean, who knows what the situation will be by the time this podcast goes to air. But the short version is that on a Friday, he was sacked by the board. Now, there's talk that one of the board members was trying to undermine the company, destroy the value, merge the company with OpenAI's competitor, and 720 plus of the employees revolted and wrote a letter saying that, Sam Altman's going to join Microsoft and we are too. And they were all tweeting or posting on X that OpenAI is nothing without its people. It was sort of post after post after post. And people in the company were very annoyed that Sam Altman was let go. Now, Sam has been involved in a number of side projects. He wants to make computer chips that rival NVIDIA. NVIDIA just posted a 205% increase on its Q3 2023 revenues. Microsoft wants to make their own chips. Sam Altman wants to make chips. And he wanted to go back on over the weekend, but what happened was he wanted some of the board members, or all the board members, to go, and obviously they weren't prepared to go. So that's when Satya Nadella, CEO of Microsoft, jumped in and said, okay, well, I'll give you a job at Microsoft. I'll give a job to the president too, who had also quit, one of the co-founders of OpenAI. But since then, a deal's been done for Sam Altman to go back. Now, again, we don't know what's going to happen. It's moved very, very quickly, and it could easily move again. But so far, it appears as though the waters have been calmed.
Why is Sam Altman so important?
He is the face of OpenAI. He's the guy that's raised billions of dollars. OpenAI was meant to be a non-profit organization. In fact, Elon Musk was even involved in it. And
That's right.
There was concern that OpenAI was moving too quickly, that the AI it was trading could be dangerous. And in fact, Elon Musk, long before OpenAI launched ChatGPT about 12 months ago, he actually offered to become the CEO, and that was rejected. And so Elon Musk left, took his $1 billion of funding with him, and that forced OpenAI to seek investment from other companies. And famously, Microsoft has invested over $10 billion into ChatGPT, into OpenAI, and that has now given us the world's most advanced artificial intelligence. Now, interestingly, since that time, 1 million AI flowers have bloomed, and one of the big competitors is Anthropic, big investment from Google, in fact, getting a big investment as well from Amazon. And they've just launched version 2.1. Now, they can now have an input of 200,000 characters or words, which is 5.5 times the amount that the priciest version of ChatGPT 4 can ingest at once, and that's the entire works of the Iliad. I mean, you can fit huge amounts of information in a single prompt. And also this version 2.1 of the Claude AI bot from Anthropic is also meant to hallucinate half the amount of time that it did before. So that means it's lying half as much as it did before. And when AI hallucinates or lies to you, it does it with incredible confidence. And look, I've been using ChatGPT version 4, and you can tell ChatGPT to check its sources. I mean, it used to be that the database only was accurate up till September 2021, but now that's moved to April 2023. But if you tell ChatGPT 4, the paid version via the app, to check the sources, it will then check the web and give you the most up-to-date information. And interestingly, people who've been using ChatGPT 4 and paying for that through the ChatGPT app on iPhone or Android can actually talk to ChatGPT ChatGPT with their voice and have a very human-sounding response in a number of different voices spoken back to you. You can have this ongoing conversation. And it was just announced that the free version of ChatGPT that's using ChatGPT 3.5, you can now talk to it and have spoken responses back as well. The other big thing about this is that there was talk that Sam Altman was in the room in the last few weeks where something big had happened, and this was something called Q-Star, Project Q-Star. And this is where the AI was able to do a simple mathematical equation and solve it. And apparently it's much easier to generate text because there's a number of different possible ways that something could be answered with text. But with a mathematical problem or equation, there's only supposed to be one answer. So this is meant to be a signpost on the way to artificial general intelligence. And so there was also concern that maybe Sam wasn't keeping the board up to date about this latest revelation. But look, there's going to be a TV show or movie about this at some point.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.